and 4 now that we're going to tape together. So we're going to continue working on the graphing. So with this graphing, first thing that I see is that there is no, oh, I have to apologize. This is page 2. Let's go to page 3. That first thing I notice is that there is no C value or B value that needs to come out. Notice that there's my floating D. And as I am looking at this, my amplitude is 2. My period is 2 pi divided by 2, which is just pi. My horizontal shift is a positive pi, and my vertical shift is -1. I also notice that this is cosecant, so I am going to be graphing my sine instead. So here is where I am starting. So I am starting at pi, and that has an end value of my phase shift plus period, means that I'm going to end at 2 pi. Ooh, this is going to be an itty-bitty wave. The 3 pi over 2 is my middle number, so now I need a spot here. This is 2 pi over 2, 3 pi over 2. This is 5 pi over 4. Add the tops, double the bottom. 3 pi over 2 and 4 pi over 2 is going to give me 7 pi over 4. So that's my first wave. 1 dot, 2 dots, 3 dots, 4 dots, 5 dots. You're starting 4 additional points. If I need the other end, I take the phase shift, subtract the period, and the wave behind is going to start at 0. So 0 to pi, pi over 2, pi over 4 would be another point, and then a 3 pi over 4. Okay, so it's going to be a little itty bitty in here, and we're going to have a vertical shift. My vertical shift is going to go straight through all of those numbers. If you guys like colors, go ahead and do the same thing that I did. Everything is based off of the yellow line. So now, for my graphing purposes, I'm graphing a sine. My sine wave starts at the yellow line, goes up to its highest point, back to the yellow line. Its lowest point would be 2 units below, so if you want me to know that it goes down to -3, label that -3, and then back up. And starts highest, middle, lowest, middle. So putting in this cosine wave, let's see if I can get this to draw somewhat nice. And I said cosine wave and I meant sine wave. There's my sine wave. Did it the best that I could. So now, since this is really cosecant, every time that green touches the yellow line, there's an asymptote. And my asymptotes are, ooh, that one is really bad. My asymptotes are where they hit the yellow line. So there are lots of asymptotes here. So for my cosecant, I'm going to have my valley, my hill, my valley, my hill. And so the red is considered the cosecant. Okay, so moving on to number 9. I see that it is a secant wave also. So one of the things that I know I'm going to be dealing with is cosine in this case. So my amplitude is 2, but it has a negative sign in front of it, so it has a flip. My period is 2 pi, and it's going to be divided by that 1/2, which means it's going to have a period of 4 pi. Horizontal shift, there's nothing hooked on there, so it's going to start at 0, and it does have a vertical shift of -1. So this one's going to be a wide wave. It's going to end here at 4 pi, and 3 pi is going to be the 3/4 mark, 2 pi is the halfway point, 1/4 is the first quadrant. So -pi, -2 pi, -3 pi, and -4 pi is my wave. It has a vertical shift. The vertical shift is -1. So everything is based off of that line. So since I'm dealing with a cosine wave and I got to go 2 units down, I'm going to 3 and up to 1. My cosine wave would hit its lowest point. Oops, I don't know why it keeps doing that. It hits its lowest point, the middle, the highest point, the middle, and back down. Starts down, middle, highest point, middle, lowest point. So trying to draw this in nice and neat. Remember, this is supposed to be a nice flowy wave. If it looks like I'm a little off, there we go. That would be my cosine wave that's got a flip to it. It hits the yellow line at -pi/3, or -3 pi, -pi, +pi, and +3 pi. Those are my asymptotes. So there's a valley, or there's a hill, I need to draw my valley. There's a valley, I need to draw my hill and valley. And now notice this would be half of a hill, and this would be half of the hill. So again, the red is going to be my secant. And last but not least of this page, again, you can see cosecant. I'm going to graph sine, but before I do anything, I have to factor that 2 out. So this is cosecant, factor out the 2, so that's going to be a theta, subtract 3 pi/4, and nothing behind it. And again, 2 times 3 pi/4, would that give me 3 pi/2? That's a way to check. So my amplitude is 2, my period is 2 pi divided by 2, or in this case just pi. My horizontal shift is at 3 pi/4, and there is no vertical shift. Okay, so I am starting at 3 pi/4. That's my starting point. And I'm going to say that this thing is going to end at 3 pi/4 plus pi, which would be 7 pi/4. It's going to be a nice little tight wave. There is 7 pi/4. Now, nice number in between, 5 pi/4. And then the halfway point here actually would be 4 pi/4, or just pi. And the number here would be 6 pi/4, or 3 pi/2. And again, I don't care which form you put them in. I put them in the other form because it made life a little easier. For the other end point, remember you're going to take your 3 pi/4 and subtract pi, which would be -pi/4. So at -pi/4, that one ends. The halfway point would be at +pi/4. And if you look, 0 would be the middle here, and pi/2, or 2 pi/4, would be the middle. There is no vertical shift. Oops, didn't change colors. There is no vertical shift, So everything is based off of that x-axis. So I am just doing a sine wave. Sine wave hits my middle. It goes up to my amplitude of 2, back to the middle, down to -2, back to the middle. Starts at the middle, the high point, the middle, the low point, the middle. So in this nice tight area, there's my sine wave. I need some asymptotes. The asymptotes head at every place the green shape touches the x-axis, which would be the first, the third, the fifth, the seventh, and the ninth point if you're looking at all of that. So this is going to have a valley, and then my hill, and then a valley, and then another hill. So the red is my cosecant wave. Okay, so that is page 3, and now we're moving on to page 4. And for page 4, we're still doing some graphing, but now we're going to be doing our tangent graphs. So for the tangent graphs, everything works the same. Amplitude is 2. It's not going to do anything. Period, though. This is the thing that changes. It is pi over b. So this turns out just to be a period of pi. The horizontal shift is at -pi over 4, and there is no vertical shift. Now, here's what you need to remember. Halfway around this unit circle is a cycle. So instead of 5 points, I only need 3. So my start is here at -pi over 4. So -pi over 4 is where I'm starting. My end is at -pi over 4 plus pi, which means this wave is going to end at 3 pi over 4. So at, oops, and I have to apologize, that point is -pi over 4. Let me erase that just to get it lined up a little better. This is -pi over 4, and this is 3 pi over 4, and halfway in the middle would be positive pi over 4. Okay, so that is a tangent wave. Now, I talk to myself as I go through here, and everything is based off of the x-axis because there's no vertical shift. And as I'm looking at this, I'm asking myself, tangent. Tangent starts, or I'm sorry, cotangent starts with C. That means that I have a continuous wave. If out of those 3 points I want a continuous wave, there is an asymptote at the beginning, and there is an asymptote at the end, and a cotangent wave starts high, it's hugging the asymptote, it hits the middle point on the yellow line, and then it comes down. So there's my cotangent wave. But you know what? I'm supposed to do that one before it too. So I need to take that -pi over 4 and subtract pi and figure out that that's going to be -5 pi over 4. So at -5 pi over 4, which would fall right about here, and between -5 pi over 4 and -1 pi over 4, -3 pi over 4 would fall. And again, my asymptote at the end, because it's going to give me a continuous wave. So it starts high, that middle point it hits on the yellow and comes down. Remember, there's supposed to be nice smooth lines this machine doesn't let me draw them that nice. So now we're moving on to the next one. And for the next one, I see that I have a tangent. I see my amplitude is 1/2, isn't going to do anything for me. That 3/2 is already out, so this is going to be pi divided by 3/2, which in other words is 2 pi over 3. Okay. Horizontal shift, there is none, but this time there is a vertical shift of 1. So I'm starting at 0, and at 2 pi over 3 would be my endpoint, and halfway would be a pi over 3. So 0, pi over 3, 2 pi over 3, those are the points. It's a tangent wave. Tangent starts with t. That means that I need 2 pieces to make a wave. That means that the asymptote would come in the middle here, so I can draw my tangent wave. But before I start drawing it, I have to put in that vertical shift of 1 that was supposed to hit 1, because the tangent wave would start there and come up high and hug the asymptote, and it would start on it and come down and hit the asymptote. Now, I also need my second wave, which is the wave before it. So 0, and I'm going to subtract that. That means at negative 2 pi over 3. And then the middle of that would be a pi over 3. And again, I need 2 pieces. That means that that asymptote is hitting that pi over 3. So my wave would start at negative 2 pi over 3 on the yellow line and come up. And it would start at 0. Don't know why it keeps doing that. And come down. So there is my tangent wave. And now for the last one. I see it's a tangent wave also. I see there's nothing to factor out. The amplitude is 3, does nothing, but the negative sign with the flip means I'm going to have to turn some things around. My period would just be pi divided by b, which is just pi. It does have a horizontal shift of negative pi over 3 and a vertical shift of nothing. That means we're going to be starting at negative pi over 3. So negative pi over 3, right about here, that's where I'm going to start. I am going to find my end by taking negative pi over 3 and adding pi to it, which would give me positive 2 pi over 3. So right about here is 2 pi over 3. And in the middle there would be a pi over 3. That's where my wave's going to be. It's a tangent wave. Tangent starts with t, which means I have to have 2 pieces. So if I need 2 pieces, I need an asymptote in the middle. There's no vertical shift, so everything is based off of the x-axis. And to get 2 pieces, it starts on the yellow, comes up. Oh, but that's a normal tangent. This one is a flipped tangent. So erase, 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 erase. And I have to start at my point and come down, and at my second point come up. Now, I also need the point in front of it. So the other end is going to be at negative pi over 3 subtract pi, which would be at negative 4 pi over 3. So 4 pi over 3 would fall in this region right about here, and its halfway point would be did I add incorrectly? No, negative 4 pi over 3. And the middle point here would be my pi, or negative 5 pi over 6. So again, I'm after tangent, so it's going to have an asymptote at 5 pi over 6. My tangent normally starts high, but it starts low, and then it goes high, and that's what my tangent has. Notice it has two unfinished waves, two pieces, starts with T. Somehow recognize that. So that takes care of pages 3 and 4, and I'm going to continue to break it down into pages of 2.